Good morning, Algebra 2, and welcome to Unit 2 Notes Day 3. Scatter plots. Let's get to it. You see all these plots here that are kind of scattered, but look how close together they are. This represents a positive correlation, and since these dots are relatively close together, this is a strong positive correlation. Here, these dots are trending downwards, from left to right, they're trending downwards. They're a little bit more scattered, but we can tell that it is trending in this direction. Therefore, it is a negative correlation, but it's a weak negative correlation. And here we got dots all over the place. That's no correlation at all. None. Approximating a best fitting line and making prediction. Non-calculator. Friendly reminder, everything you see me do without a calculator, you're going to need to know how to do without a calculator. And everything you see me do with the calculator, well, then you can use one. So if we're going to find the equation that is going to help us with not only the information at hand, but predicting future information, let's take a look at this line of best fit that they have provided us. Now, you're going to have to sort of, I'm not going to zoom in any further. This is kind of difficult to see, but you can move your face closer to the paper. Let's start here on the y-axis, and then I'm going to put another dot there. So if you're using your change in y over change in x, that's going to be 750 minus 700 over 2 minus 0. And if you simplify all that, we now know what our slope is. Our slope is going to be 25. So let me start by writing my equation. Y equals 25x. Our y-intercept is 700. So plus 700. This equation here is going to help us predict other types of data, such as if this trend continues, predict the number of people that will attend the 10th football game. Your X values represent the number of games here. So if they want us to predict the 10th football game, you would just take the number 10, substitute it there for X, and then you could solve. So Y equals 25 times 10 is 250 plus 700. So we can guess that there's going to be 950 people at that particular game. It asks us here, what type of correlation is this? Well, we can tell that these dots are very, very close to that linear line. So that is a very strong positive correlation. And then how closely does the line fit the data? Now it looks very close to me. So you just put very close. All right, what they want us to do for this next section is they want us to take the X value here and the Y value there, plot them on this graph, and then draw a line of best fit. And then take the X values here and the Y values there and plot them on this graph, and then draw your line of best fit. Well, let's just do that once. So I'm going to get rid of this column here. Let's plot the point 9, 26. Right about there. Now 12, 33. $14, 40.1. 16, 54.7. And 18, 64.6. And then they want you to do the best you can to draw a line of best fit. Try to just go between them. Maybe right about there. That's not too bad. That's how you would do that particular section. Move on to side 2. And now we get to the nitty-gritty. Calculating a linear regression. See the step-by-step directions sheet provided. So you should have that included with your notes. But I'm going to show you what you're going to need to do here. The table shows the percent of US households with internet access. Let X be the number of years since 1995. Well, this top column here, this top row here is our X values. And the bottom row is our Y values. They tell us that they want X to be the number of years since 1995. Well, since we start with 1997, that's 2 years away from 1995. 2000 is 5 years away from 1995, and so on. Let's just fill in the rest. Now, to perform a linear regression on your calculator, you might have to set some things up first. Is that better or worse? All right. Oops. Hang tight, everyone. Presto. Okay. Here's what you're going to want to do. Start by hitting second and then 0. Second, 0. Scroll all the way down until you get to diagnostic on. Then hit enter once, twice. Okay, we should be good to go. Next. Oh, by the way, I'm using a graphing calculator. That means you can use one. You're going to need one. If you don't have it, get it. Maybe pause the video and get it if you don't have it out. All right. We're going to enter this information into our calculator. Start by hitting the stat button. See it? It's the one that says stat. Hit that. It's currently right where we need it. We need to edit some data here. So push enter. The L1 column are all of the X values. So we're going to begin by doing 2, enter, 5, enter, 6, enter, and so on. Once you've done that, scroll over to the L2 column. Those are going to be all the Y values. Enter those in. Now, if I were you, I'd just double check just to make sure you entered everything in correctly. After I double checked, I entered everything in correctly. So now you're going to hit the stat button again. This time scroll to the right once. And you're going to select that option right there. We are performing a linear regression. Push enter once, twice. Just keep hitting enter slowly until you see this information on our screen. Now, before I explain what we do here, here's what we've essentially done. Remember on the other side, when we came up with this equation here, we looked at the data, or we looked at the line of best fit, and this is the equation we got. Well, we've done that without the aid of a XY coordinate plane. We've entered the data, and it's told us this is the linear regression equation that you're going to want to use. The A value is going to be our slope. The B value is going to be our y-intercept. The r squared value, you're going to ignore for now. And the r value is the correlation coefficient. That tells us what type of data we're dealing with. And I'll also explain that as we progress. Now we can begin answering. Perform a linear regression on your calculator. Write the equation below. We just did that. This is the linear regression. And it didn't tell us where to round here, so how about we just round to the nearest 10th? So start with y equals, remember, the A value is our slope. 3.4x. Our B value is the y-intercept. It's positive. So plus 22.0 if you wanted to round to the nearest tenth. Well, we could leave it as 0. That is our linear regression equation. Part B, it asks us, what is the correlation coefficient? That's that R value right at the bottom. Let's round it to the nearest tenth. 0.9. Is the correlation weak or strong? It is strong. Well, let me be more specific. It's strong positive. The closer this number is to +1, the stronger positive your correlation. The closer it is to -1, the stronger negative your particular correlation. Part C, use your calculator to predict the percent of households with internet access in 2017. Here's what we're going to do. We're going to use this equation that we had earlier, except instead of x, we're going to plug in a number. All right, so use your calculator to predict the percent of households with internet access in 2017. Well, remember, here's 2011. That was 16 years away from 1995. So if we're looking for now 2017, well, that's just 6 years away from 2011. So we want our x value here to be 22. That's what you're going to substitute here. And then plug it in. Let's see what it is. Wow, that is quite a figure. 96.8. 96.8%. That's what they're thinking. Example D. During what year will the percent of households with internet access be 75? Remember, that's our y value. 75%, that's our y value. So we want to take this equation, except this time substitute 75 for y. All right, subtract 22 from both sides. Then divide both sides by 3.4. $15.5. Well, remember, we're talking about a year here. So we're currently in the 15th year. We haven't made it all the way through yet. So we are in the 15th year. 15 equals x. And now we can go back to our chart here. Well, if the 14th year is 2009, then the 15th year must be 2010. So that's the year that they're going to be at 75%. Example 2, the table shows the number of employees of a small company. Let x equal 0 be the year 2000. Well, 2002 is 2 years away from 2000, so we need to number our x column accordingly. Okay, perform a linear regression on your calculator and write the equation here. Let's start by hitting the stat button. Enter. I'm going to go over to the X column, the L1 column, and put our X values. And you could delete all this stuff, all the previous data. Just do it slowly. There we go. All right, let's enter in the X values now. And now the Y values. hit that stat button again. Scroll to the right once. Select linear regression. That's what we need right there. How about this time, let's round to 3 decimal places. So y equals the a value is going to be our slope. Our b value is the y-intercept, and it's negative, so make sure you write minus. There is our linear regression. Next, what is the correlation coefficient, and is it strong or weak? Wow. Let's round to 3 decimal places. The r value is the correlation coefficient, 0.995. That is very close to +1, so it is strong positive. Example C. According to this model, in what year would the company have 30 employees? Employees. That's going to be our y value. So let's use our equation here, and we're going to substitute 30 for y. And then begin solving for x. Let's add this first. Now let's divide both sides by 3.914. Let's bring out our graphing calculators. Let's do that math. I like using the fraction symbol when I can. But you can just divide them normally. Make sure I got all those numbers right. We're looking good. Okay. Now it wants to know what year. 8.8. You're going to be tempted to round up. But if we're 8.8 years into the making, we're still in year 8. So we're just going to say we are in year 8. That's our x value. And then if you go to your chart here, year 8 must be 2008. So that's the year we expect to have 30 employees. We really need to update this. And finally, how many employees would there be in 2017? Well, 2017 is 17 years away from 2000. So we just want x to be 17 here. So let's use this equation and let's let x be 17. All right, plug that into your calculators. Did you do it? Did you plug it in? Is that what you got? You should. We expect to have 62 employees. Well done, Algebra 2.